Today I'm going to talk about picking the perfect brain for your robot, which is the microcontroller. When we are talking about microcontroller is the brain of our robot, right? So we have to select the perfect microcontroller and the best suit microcontroller for our robot. Otherwise, we cannot do the all the tasks that we are wishing to do by our robot. So to find the best microcontroller for our robot is crucial, and there are a lot of microcontrollers in the market. So we have to choose the best one, so and the most effective one. So today I'm going to give a simple guidance about how to select a microcontrollers that suit for your project, and based on microcontroller, how to select the suitable development board as well. Okay, so and the first thing is why we need microcontrollers inside our robot. Right? So when we are developing a robot, the most of the times we have some special task that we are going to do using our robot. For that, we need a lot of sensors and motors and servo motors and everything we need. And uh, we are going to control all of them using our microcontroller. So just examples like sensor interfacing and data acquisition. And when we are developing a robot, we need a lot of sensors, and another thing is we have to make that decision flow accordingly, and we have to control logic as well, and the actuators, servo motors, and other things. We have to control them according to the input given by the sensor. And timing and scheduling, we have to schedule the tasks that should done by the robot in a ordered manner. And another thing is communication, right? So Bluetooth communication, Wi-Fi communication, and everything, and the power management and the user interface handling. So uh, in user interface handling, when you are if you are developing a remote control robot, so you have to use Wi-Fi or Bluetooth to connect with the user and the robot, and they are to display the things that the user should see. All of these things also processed by our microcontroller. So the we have to according to our project, these things may be different, but according to that our requirements, we have to choose the best microcontroller for our robot. uh, so uh, in this presentation, I have divided the robots into three main categories. So and based on each category, I'm going to suggest and recommend some uh, most used development boards and the microcontrollers for each project. So in the basic robots, I have added just the simple robots that as the entry level robots that we build when you are going to do robotics. First one is that the line following robot and the obstacle avoidance robot, those things. I categorize them in the basic robots, and the intermediate robots are just navigation boards, micro mouse, and self-balancing robots like that. Going The intermediate robots and the advanced robots are the robots that use computer vision and AI models and ML models that run inside the robot. So those are my three categories, and I'm going to explain the controls that we can use in each category. Uh, and then when you are moving on for the basic robots, we need there are several requirements that we are going to that we need to fulfill using our microcontroller. So when if you are developing uh, a line following robot like this, we need IR sensors and the motors and the battery. So we have to connect all of these things, and it doesn't require that much of processing power. It had only low processing power, a limited number of sensors. We need some number of IR sensors and only two motors, like. And the logic is simple also, and the minimal communication required actually this does not need any Bluetooth and Wi-Fi connection, and the low power as well. So those kind of robots, there are a few most used microcontrollers and the development boards. The first one is ADMEGA 3280P microcontroller. So it has 16 megahertz clock speed, and I'm not going to explain all of those things. And digital pins, it has 23 digital pins, and analog input pin 6, and PWM output pin 6 of them. And the communication interface IVRT, I2C, and SPI they use for the communication, and but they don't have any built-in Bluetooth or Wi-Fi uh, inside the Atmega 32P microcontroller. So the development boards that built using Atmega 32P is Arduino Uno and Arduino Nano, very popular development boards and the entry-level development boards. We have actually, when we are selecting the microcontroller, we have to select the suitable development board as well when we are. So both of them has the same microcontroller, but they have different. The appearance is different, and we have to choose the best one suit for our project among them as well. So in Arduino Uno, we use this for basically for learning stuff, and the Arduino Nano we can use this for to develop variables and other things, because it is small, and we can include this inside any inside our variables as well. So we have to the thing is, we have to consider about the microcontroller as well as the development board as well when we are developing a robot. And the next microcontroller that we can use for basic robots is STM32 F0 series. This is a series of microcontrollers, and these values may be vary uh, based on the configuration, and it has average of 48 megahertz speed, and 30 to 50 digital pins, and analog input pins they don't uh, uh, define that separate, but 16 channels for that, and it doesn't have built-in Bluetooth and Wi-Fi capabilities. So STM32 F0 series microcontrollers also we can use for basic robots. And here are some development boards that are built using STM32 F0 microcontroller, and Nucleo F0 308 R8, and the STM 32 F072B Discovery microcontroller board as well. So we can use this for those basic robot stuffs as well. And then another thing is ESP3288 8266 microcontroller, and it has some more capabilities rather than STM F0 and Mega 328P, which is the clock speed is a little bit high, and it has digital pins to 16, but the downside is it has only one analog pin. So if your project require a lot of analog pins, it's better not to use this ESP8266 microcontroller. And another strong thing is it has built-in Wi-Fi capabilities for if you are going to develop a basic remote control robot or something. It's better to use this microcontroller for your project. So this is the microcontroller, and this is the development board that built using this one. And then we can move on to the intermediate robots. So those robots uh, we need all the things that we use for the basic robots, and some additional things as well. So in intermediate robots that we are developing the micro mouse or something, some robot like that, we need a lot of sensors. So we have to take care of the real-time sensor fusion and the PWM motor controllers as well. And the other things are same. And if we use more sensors and more actuators, you need more pins, more input and output pins, and the more processing power is required for the intermediate robot. So we have to select a suitable microcontroller that can fulfill all of these requirements. So we can go through it. And then first thing is ESP32. ESP32 is one of the most commonly used microcontroller, and I actually forgot to talk about my programming languages. In ESP32, we can code this using MicroPython, and using Arduino IDE, we can code it using C and C++ as well. And so in the clock speed is little more than basic robot. It has 240 megahertz clock speed and 34 GPIO pins and analog pins 80 for 18 channels support, and PWM pins on 16 channels. So it doesn't unlike the Atmega 328P microcontroller, that this one doesn't define that as analog pin or PWM pin. We can use those pins for that purpose as well. And it has both inbuilt Wi-Fi and Bluetooth capabilities, so we can use this for IoT projects and the robotics projects as well. So there are two most commonly used development boards using ESP32. One is ESP32 development board. This one with the ESP32 microcontroller, and the other one is the Magic Bit. This Magic Bit is mostly developed for the STEM learning, and it has built-in two push buttons and a speaker and OLED display as well. So we can connect other devices using these pins as well. So those are the microcontrollers that use ESP32 chip. And then another microcontroller is STM32 F4 F4 series or F7 series. So they have some more clock speed from 180 to 300. So it varies depending on this which model, which microcontroller that you are going to buy, and it has more pins. So 114 pins has those STM32 F4 and F7 series. So if your robot require a lot of pins and use a lot of sensors and a lot of actuators, you need a lot of pins. So you can use this microcontroller for your robotic project if you require a lot of pins. And the analog input pins there is supposed for 24 channels and PW output 12 plus channels. And it doesn't have Wi-Fi or Bluetooth inbuilt. So you have to use another microcontroller for that purpose. But it has a lot of pins. So you can, for most robotic projects, we can use this if you use a lot of actuators and sensors. And these are some examples that use built based on STM32 F4 and F7 microcontrollers. One is STM32 F4 discovery board, and we can connect a screen and everything to this board. And another one is that this use STM32 F4, and this is built using STM32 F7 and the Nucleo F7 607Z1 microcontroller. And yeah, so that's about this intermediate level projects. And then we can move on to the advanced robots. So when you're talking about advanced robot, those things are just not the robots, so we can't use, they are actually the computers, so we can't use microcontrollers for the advanced robot. Mostly we can use microcontrollers to control the sensors and the actuators, but we should use something that has more computational power rather than the microcontroller. For that, we use single board computers. We use that to process on-board image processing and machine learning, to run machine learning models. And another thing is we need a large RAM and storage for those kind of robots. And another thing is OS support is required, and the power management. We have to consider about the power management as well when we are going to build advanced robot, because it has more sensors and more powerful actuators. So we have to consider about the power management and for the board as well. And there are plenty of single board computers, and one thing is Raspberry Pi 4 and 5 also there are now, and we can use that we can code using this Raspberry Pi 4 Raspberry Pi single board computers. They have a separate operating system, Raspbian operating system, so we can install that on the board using the SD card, and then we can code that using the Linux environment. And the processor that used in Raspberry Pi 4 is Broadcom BCM 2711. 11, and the clock speed is 1.5 gigahertz, and it has the RAM of 2 GB RAM, and it has 40 GPIO pins, and has the built-in Wi-Fi and Bluetooth capabilities as well. So when we are, but we have to make sure that when we are using a Raspberry Pi or some single board computer, we should use this to only to process those advanced computation tasks, not just to control that actuators and sensors, because we can use separate ESP32 or STM32 for those purposes, which is connected to this Raspberry Pi, because it has four USB pins and the Ethernet pin, so you can HDMI pin and port and USB ports and HDMI ports, so you can connect those microcontrollers to this single board computer, and we can control the sensors. So only the it's better only to compute that computer vision things and machine learning things inside this Raspberry Pi or any single board computer. So if you are going to do some more advanced AI capable projects and AI involved in robotics projects, you can use these development boards as well. So they are pretty expensive. So one thing is Jetson Orin Nano uh, uh, single board computer. This is developed by the NVIDIA, and it has it is the, I think this is the latest one developed by NVIDIA. So it has a lot of computation power. Even the large language models can be run using this Jetson Orin Nano, and this came after the Jetson Nano, which is not available now. It was launched, I think, 6 years ago, but this was launched very recently, and it supports TensorFlow and PyTorch as well, and we can run large language models in this one as well. And when we are the last one, Jetson JVNX came before Jetson Orin, right? Yeah, and this one we can use special design for the medical task, and some require. This is the most powerful one. This one is not that much powerful as just ignoring. And then we have Coral development board developed by the Google, and we can use this one for the AI related computation task as well, and to run machine learning models on this development board. Yeah, so that's about all these AI capable development boards. And so when you are choosing your microcontroller for your project, you have to consider on all of the things that what are the things that you are going to build using your a microcontroller, and what are the capabilities that your robot should have, and accordingly you have to choose the microcontroller that you are going to use. Otherwise, when you are doing the project, when you require more sensors and more actuators, you have to change. Sometimes you may need to change the board as well when you're developing it. So you can avoid those things by uh, before starting the project. You have to consider about how many motors I'm going to use, how many servo motors I'm going to use, and how many sensors, and if I'm going to use a screen, or are there any machine learning models that I should run on the robot likewise. So you have to consider about those things, and based on that you can find the best development board and the microcontroller for your project. So that brings an end for the today's session. And yeah, if you have any questions, you can ask. And thank you very much.